Two and a Half Admins, episode 122. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your classic Clara plug is OpenZFS choosing between FreeBSD and Linux, written by Jim.
Yeah, so this basically just talks about the differences between running OpenZFS on FreeBSD compared to Linux and helps you decide, which one might be best for you depending on which features you're going to use.
Which, honestly, spoiler, there's not a ton. We go over what few there are, but click in and read the article to find out exactly what they are. But short version is you should probably use the operating system you want to use, and ZFS is great on either one.
Exactly. And it does have some of the caveats if you're actually moving the pool back and forth between them as well.
Right, well, link in the show notes as usual. The Intel on-demand driver is going to make it into Linux 6.2. So this is coming very soon. We still don't know very much about it, but essentially it's kind of paying to unlock features on Intel hardware. And this rubs me the wrong way.
It absolutely should rub you the wrong way. It should rub you the wrong way as a Windows user, let alone a big, filthy open source hippie like the three of us all are, in our various ways. The on-demand thing, if anything, it's almost worse than it sounds. There are two different license models for the on-demand features that you can unlock in these newer Xeon CPUs. One is a straightforward, you bought the license and now you get to use the feature that already existed in your CPU. Hooray! The other one is even worse. It's a consumption model, which means that you pay. Now, we don't have a whole lot of details on this yet. Intel may not have fully cooked all of the business side of things yet, but they've made it relatively clear that one way or another, the consumption model boils down to rent the feature in your own CPU that you purchased for only the amount of time or units of work or whatever that you are using it. So you could buy your expensive new Xeon server CPUs and then later decide, hey, Intel, I don't want to pay you enough money to actually have access to all of the instruction sets in these CPUs, but how about I just throw you a few bones, right now for, like the next 8 hours or so to use them? Ugh.
Looking at the vendors that they selected for this, for example, Supermicro is only on the activation model where you turn on features. And it seems to be specifically cloud providers that are on this on-demand model. So it sounds like the idea is the cloud provider will buy the high-end CPU with all the features, but them turned off and be able to bill customers to activate the features for runtime in the cloud like you would with the whole machine. So that the cloud vendors don't have to pay Intel for the feature all the time it's not being used.
That is entirely possible. However, I do want to stress, all of the information really that's available on this is one single, very short marketing page at Intel.com. And we're really just guessing by the fact that HP Enterprise, a cloud vendor, is over on the consumption side, and Supermicro, a hardware vendor, is over on the activation side, where you just unlock the feature and it's yours for the rest.
Well, in particular, I saw Phoenix Nap is on the consumption side. And I was like, they don't sell hardware to anybody. And that's the one that thought, maybe this is really geared towards hyperscalers.
But then Lenovo is consumption and activation.
Yeah, it does sound like for some of this they wanted support, and even HP's marketing around it is talking about, for your own hybrid cloud and so on. And I suppose maybe it makes sense, but it seems awfully weird to me. I'd like to also get more clarity on which features. Like they talk about Quick Assist, which is the encryption offload stuff. And if suddenly I have to pay extra for that, not going to be happy. But the fact that before this, for quite a while, if you wanted the SHA new instruction to make SHA-256 and 512 faster, you had to buy a gold level Intel CPU. The silver ones just couldn't have it. If I can have a silver that has it and just pay a little bit extra for that instead of having to buy a gold CPU, maybe that is a win for me. Although how you have to activate it requiring a special driver and putting a license file in sysfs or whatever on Linux seems super sketch to me.
I'm sorry, but no, it's not a win for you, period. It's not a win for anyone. It's just another way to just extract money for the purposes of extracting money. I did not like it when in the earliest days of the Celeron, a lot of people don't realize this, the first generation or so of Celerons were not a separate product line. They were Pentiums that came off the product line, perfectly functional, that Intel lasered off 3/4 of the on-die cache. That's what made them Celerons. They had less cash, not because they were built that way, because Intel literally zapped them with a laser to physically remove it before selling it for less money to customers. So it actually cost more to make them.
The activation model is one thing, but the consumption one sounds an awful lot like monthly recurring revenue to me, which is what all businesses want. It feels like the Intel management types were sitting around in a meeting. I like what Adobe are doing. Give me some of that.
Yeah, hard agree.
And definitely, the fact that you see, even if a company, after they've done 5 or 7 years out of their server, they sell it to somebody who then, ends up on Unix surplus or whatever, and somebody buys it and runs it in their home lab. It's like, we could be getting money out of these chips for like 10 plus years. CPUs don't generally die, especially the server grade ones. I know people still rocking pre-E3 and E5 CPUs, like the old X520s or X5200s. Yeah, if Intel could be getting money even just annually out of those, that would be a lot more money for them.
And let's just go ahead and point out now, the one aspect of this that we haven't talked about yet that is truly horrible. Any of this, licensing for consumption, on demand, blah, 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 it stops working once the back end goes away. There was a story that came out today about Epic apparently has turned off all the servers for the original Rock Band game.
Yeah.
Which, makes it effectively unplayable. So, you have one of these CPUs. What happens 20 years from now when Intel has moved on to a different scheme? It's just like, screw it. We'll just turn that off. Okay, great. So now there's this half-broken hardware, littering the planet. And it's not the end of the world in the sense that, probably you shouldn't be using 20-year-old CPUs in production. But still, it just, I don't like it, man. I don't like this forced obsolescence crap. I don't like things that are just extra care is taken to make them less usable. It rubs me the wrong way.
Well, so this requires Intel actually phone home?
We don't know, do we? That's the problem.
Yeah, because if it does, then it probably also specifically impacts the resale value of the CPUs and the salvage value. Right? Like we just mentioned buying a machine from Unix surplus, but if the CPU's tied to somebody else's Intel account, then how do I even pay for it in order to get the features out of the CPU?
Well, think about it for a minute, Alan. I mean, the activation model, in theory, you could phone home once, right, do your license check, then flip on, that feature and leave it flipped. But if you're doing the consumption model where it's on demand and the amount your bill changes, based on your usage, how can that possibly work without phoning home to a back end?
Yeah.
It took me a while to come around to the idea of, licensing software, like what Adobe does. There are pros and cons to that model, and for the most part, I'm pretty much okay with that now. You never really did own software in the first place, so the license model kind of makes sense. And if sometimes those are permanent licenses, sometimes they're renewing, okay, fine, I get it. But the thing is, when you do that model with software, you rent the software. Okay, fine. But Intel's not sending me a Xeon Scalable for free. They want me to buy it, and then they want me to rent its features. And that's just never going to be okay.
Yeah. And generally with the software you're renting, you're also getting updates, right? This isn't a new version of eMachines where Intel promises that, they'll give me a better processor next year if I keep renting it or something. And so, it's just not a good look. And it does, raise questions about the resale value and so on, and even just the way licensing works. And I'm starting to have recall to some of these things with GPUs. About 10 years ago, there were certain class of ATI cards where there was a 6990 and a 6970, and they were basically the same card, but the firmware made the 6970 slower by just not accessing the last little bit. And they didn't bother to laser off the extra feature. They just disabled it in firmware, which meant with the little hex editing or whatever, you could flash new firmware on it that suddenly made it a 6990 instead of a 6970. And with how well Intel has done with adding new features to the CPUs like SGX and so on, where they've actually, we have to not use that because it's terrible or it's broken or it doesn't actually work and we've just disabled it. What are the chances somebody's going to figure out how to activate these features without paying for them? And then what happens? And, if Intel's having to phone home all the time, even for the activation version, I'm not a huge fan of this idea at all.
A huge story that the EFF got involved with was these killer robots in San Francisco. And first of all, it got approved and there were going to be killer robots, and then they voted against it. And so for now, the police aren't going to be using killer robots in the San Francisco area. But we'll have to see how long that holds. This all feels very dystopian.
I would just like to point out that fully automated devices with lethal capability are a war crime. You're not allowed to build turret guns, sentry guns for your military to use. The idea that San Francisco civilian cops were considering this, it blows my mind.
Were they going to be fully automated, though?
It didn't seem like it necessarily, but if they have the ability to make that decision, then doesn't matter how fully automated it was.
Our boy Elon's right there on hand. I bet you could adapt the full self-driving beta to one of those robots.
Yeah.
Just a couple hours of training and that model's going to be good to go, baby.
Yeah. How much per month is that going to be?
Yeah, and what happens when somebody stops paying the Intel license on the CPU in the thing?
Maybe it'll get tied into the new automatic moderation on Twitter as well. Make fun of Elon offering that girl a horse one more time, and we're going to send the killer robot army to your house.
Well, more on that next week, probably.
I can see some of the appeal, with how problematic individual people can be and the level of institutional racism and so on that we see in some police forces. But the robot's not going to be any better if the data it's trained on is just as warped. We've seen what badly trained AI can do, whether it's just the early versions of the Zoom face tracking filter deciding that the lampshade behind the person with a dark skin tone was actually the face, not the person with the dark skin tone in the picture. It turns out if you train all the data on white faces, it's going to try to find the thing that looks most like a white face, and that's not going to be the thing that necessarily looks most like a face.
Yeah, I remember the Twitter image cropping.
Yep.
And how that was pretty racist as well, yeah.
To be fair, and this is my fault, we're going off a lot on AI here, and there may not be any appreciable AI involved. It may be pure and simple remote operation. It appears they want to adapt existing bomb disposal robots for this, in much the same way that in Texas a couple of years ago, without an actual program, they just used a bomb disposal robot to tote a bomb up to kill somebody that was shooting cops. But this is still problematic without the AI angle whatsoever. It's very easy to say, oh, well, how can you expect officers to, put their bodies on the line and yada, yada, yada. But I would we need to point out here that policing is not actually a notably dangerous job. It does not even make the top 10 list for dangerous jobs in the United States. It is not as physically dangerous to be a police officer as it is to be a lumberjack, a farmer, a forestry worker. I mean, there's, let alone, working the counter at a 7-Eleven. Are we giving those guys killer robots? Like they're not just behind the bulletproof glass now. They've got an armed robot on your side of the Lexan. Maybe I'm in favor of that one. We keep things orderly in our 7-Eleven, son.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. A lab in California has achieved nuclear fusion ignition, which means they got more energy out than they put in, asterisk, to a nuclear fusion reaction. This is potentially a giant leap for mankind.
Yeah. What's interesting about this model versus the previous ones is instead of trying to spin things around really fast and smash them into each other, it's using a laser against a fuel pellet. And in this particular case, they managed to get more energy out than it took to put into the laser, which previously they'd only gotten relatively close. If they can keep repeating this, then that's really good news, but this is still quite a ways away from being able to be scaled up and made commercially viable.
It may or may not be one laser, but just to be clear, it's 192 laser beams hitting the pellet. And yeah, this is a really big deal. To be clear, it's the first time we've gotten a controlled net positive, more energy out than energy went in. We have for a very long time been able to get more energy out of a fusion reaction than went into it. We call that the hydrogen bomb, which requires a fission bomb in order to compress the hydrogen enough to cause fusion, which then lets the big boom come out. But the thing is, you're basically creating a small slice of the actual sun on planet Earth when you do that. There's not a whole lot in the way of material technology to contain that. Being able to make this reaction happen in a controlled laboratory environment and get more energy out than you got in, that's the new thing. We have literally never been able to do that before. Now, right now, it's not enough energy to get excited about. There are almost certainly other operational problems that we really don't know about from the abstracts that we can get from news sites and what have you. But this is still a big deal. It's not a big deal for this year. It's probably not a big deal for 10 years from now. But, 20, 30? I mean, we really have unlocked a door here. It's going to take us a while to wedge our way through that door, but we weren't even sure it was a door until this.
That is true, but the asterisk that I mentioned was that it's like a microwave, right? Like you put your microwave on 800 watts or 1,000 watts. It's not actually using that from the wall. If you plug a kilowatt in, you'll see it's using way more than that. And the output of the lasers was less than the output of the energy that they got from the reaction. But the input to the lasers, because they're inefficient, was way more.
The lasers output about 2.05 megajoules, and the reaction produced 3.15, which is about 50% more. But like Joe said, it took a lot more electricity than that to fire the laser because the laser itself isn't that efficient yet.
Yes, that is one of the many caveats to this laboratory prototype demonstration. But if you want to look at the glass being half full rather than half empty, you can say, well, that leaves us any number of ways to resolve that, because we can resolve that by getting more energy out of the reaction. We can resolve that by figuring out a way to sustain the reaction where the lasers are necessary to ignite it to begin with, but then it can self-sustain the way that a fission reactor does. Or it also leaves open, the possibility that maybe we will have more power-efficient lasers later on down the line, and that resolves the issue.
Yeah, like if I remember correctly, originally the best they had done was getting about 80% of the laser's output as output from the reaction, and now they're at 150%. Like Jim says, if they get much higher than that, then it can make up for the inefficiency of the laser. And then again, if it can sustain itself once it's ignited, most power plants actually take quite a bit more power than they can produce to get started. That's why a black start of the power grid is such a big deal.
It's just so hard to get excited about because it's still so far away.
We've been 20 years away from this since the 50s, but yeah, this is a big breakthrough, and hopefully we can continue to make advances more quickly now.
I do not find it hard to get excited about this. I just know that I'm excited about a thing that it's in its very, very early days. I'm not excited about a consumer accessible product or service coming out anytime soon, possibly not even while I'm alive. But controllable fusion, that's one of those really big sci-fi goals that it's like, we're literally not sure if this is ever going to be possible within the boundaries of physics, Like faster than light travel was easy to get excited about the idea of in the 60s. Well, I got bad news for you. That's almost certainly never going to happen, not because our technology isn't sufficient, but because the laws of physics say no. You can't do that. And there was a real question whether we would ever be able to actually contain a fusion reaction that we got more energy out of than we put into it. The fact that somebody managed to do that, yeah, that's a big deal. It means that now we have a massive engineering problem to overcome rather than figuring out whether or not the law of physics will allow us to accomplish something that would be amazing.
Yeah, big engineering problems are great because it means you can actually do them. It just takes a bunch of work. other random thing I wonder about is, Lawrence Livermore National Labs. Where have I heard that name before? Oh, right. That's the people that ported ZFS to Linux. I wonder if the giant Lustre cluster they have on ZFS is to store data about this experiment.
You literally couldn't help yourself, Alan, could you? You had to crowbar ZFS in.
Actually, Alan didn't even break the cherry on that one. I have already seen that speculation on Twitter and on Reddit about, ZFS being a part of this because it happened at Lawrence Livermore. And no, I didn't see it because I posted it either. I did think it, though.
Well, I'll get properly excited about this when I can pour half a can of Miller Lite into my car and have it run and fly. But I might be waiting a long time.
This is not Back to the Future 2, and Mr. Fusion is not a thing, Joe.
Damn it.
It could solve our energy crisis if only we can get there.
Or it could be used to replace the scrapped plans for the Nerva rockets back in the 60s and 70s.
Yeah.
There was originally a plan to use fission reactors, basically, to produce the power to accelerate reaction mass for interplanetary travel across, deep places in the solar system. You can get way, way more energy out of a lower mass of spacecraft if you can accelerate the reaction mass with something a lot more powerful than just the chemical explosion of something going boom. There were tons of tests done. Ultimately, the plans got scrapped. The Nerva series weren't just designs. There were actual laboratory engines created and tested. This was a long-running program with several iterations, and the original plan was that Nerva systems would be used to travel to, Mars, to the outer planets, you name it. They got scrapped in the 70s during the big economic crisis, around the Carter era. But as powerful as a Nerva system using 1960s fission technology would have been, imagine what you might be able to do with fusion.
Yeah. I guess just to bring it all back together, the other advantage of these fusion pellets that they're using at LLNL is it's basically deuterium and tritium, which are both isotopes of hydrogen and can be made from seawater. Deuterium is also known as heavy water. It's what Canadian nuclear fission reactors use.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. And do send in your questions. And like I always say, the shorter the better. Another perk of being a patron is you get to skip the queue, which is what Craig has done. He writes, I was curious if you guys have ever worked with FP-Sync. My use case is to transfer a lot of files from self-hosted NFS servers to Amazon EFS. Just curious if you had any thoughts or other recommendations.
So I haven't used FP-Sync, but I've heard of the author before and I read a bit about the tool. It looks like a nice tool for parallelizing rsync. So it basically walk the directory tree and start building a list of files and run multiple instances of rsync to copy the files more quickly than a single threaded version of rsync would do. So it sounds like a reasonable tool to start this migration. The only caveat that it would have is the same ones that any regular rsync job would have, is if the files are changing while you're copying them, you can end up with inconsistent versions at the other side, especially any big file. If you're copying it and you're halfway through and something in the beginning of the file changes, rsync's not going to catch that until you do another pass later. So using FP-Sync to get the bulk of the data up there will be really good, but you do have to do some kind of sync at the end where you've stopped the files from changing on your end. But, if you're talking about a huge amount of data, using this to get a lot of it up there much faster will save you a lot of time. Just know that you are going to have to do a consistent sync at the end where the files aren't changing while you're syncing.
This is assuming that consistency actually specifically matters, which it does for a lot of workloads. It does not for some others. Like, you don't necessarily care too much about consistency if you're just using rsync or a script based on it like FP-Sync to back up just, a generic collection of files on a NAS. It doesn't particularly matter if one changed, during the backup run. If it did, then you'll catch the new version the next night, et cetera, et cetera. It's nice, but not necessarily crucial. Where it becomes crucial is when you've got, one file that depends on the state of another file. And you can end up having one file get changed in a way that those two files would never, ever have that relationship the way it becomes if FP-Sync gets the newer version of the one that should have changed second, but the older version of the one that should have changed first. The other thing I'll mention is FP-Sync It's not just a speed up thing. Running multiple rsyncs in parallel over one large file system will also result in lower memory usage than one single whopping gigantic rsync run over the whole thing, because rsync has to build a table of every single file in the thing that it's synchronizing and compare it with the state of every single file on the remote end as well. And there are fewer of those comparisons to run when you split it up into multiple jobs. So there are potentially other benefits there. Basically, the use case that Craig is talking about, migrating a bunch of files from self-hosted NFS to Amazon EFS, that is exactly what this tool was created for. It will work as well for that or better than it will for literally anything else, because that's what it's for. But like Alan said, consistency is going to be your potential bugaboo here. If you need consistency, you're going to need some way to key-s the source before you start your FP sync run, or clean it up, by key-sing it after the initial run and then doing a second cleanup run. Or, obviously this doesn't work for Amazon EFS, but this is Jim Salter and Alan Jude, so I'm just going to mention, if you use ZFS replication, you don't have this problem.
Yeah, or even like if you are having to use rsync to copy it to EFS, if you can rsync from a snapshot to EFS in the beginning, you're going to get a consistent copy of it there. But I think for this question, a lot of the weight is sitting on the specific wording. He says, my use case is to transfer a lot of files. By transfer, does he mean, like Jim said initially, maybe just backing them up? And that means one thing. But if he means transfer as in migrate, as in I'm going to get rid of the self-hosted NFS servers at some point, then that's where the consistency part can really come down to mattering, because, you're not going to have future backups that are keep going to update these files. And so, yeah, like Jim was saying, I think your best bet there is use FP sync to parallelize and get that stuff up there, because you can tell it, tell each rsync to only copy 1,000 files, then quit, and then they will use less memory and be much quicker, like Jim said. After you've got a copy of all the data there, and you've got maybe even another incremental since then done to get caught up, because the initial job might take weeks or months depending on how much data you're talking about. At some point, you do have to quit. You have to stop the local self-hosted NFS servers from changing and copy the last couple things that changed, so that what's in EFS will match exactly. And it's hard to do that if it's constantly changing.
I think that only becomes easier if you're talking about a permanent migration rather than a backup, because that just means you're guaranteed going to be key-sing the old crap. You do your initial run, then you do a second, much faster run, then you point all your services to the Amazon EFS rather than to your old NFS. Presto, your NFS has become key-s'd. The only thing that you need to do now is the next time you do your final FP sync, you've got to pass it the rsync argument to only sync files that are newer on the source than on the destination, rather than all changed, and problem solved.
Yeah, something to that effect. But if you are doing the backup thing, then like Jim and I were saying, what you want to do is make a snapshot and FP sync the snapshot to Amazon, so that, if it takes hours to copy, you have all the files as existed at the second of the snapshot, especially if one of the things on your NFS is something like VMDK or like giant virtual machine image files, or any kind of large file that's going to have lots of small changes scattered all over it.
Database binaries, the ultimate horror.
Yes, the databases, anything like that, them being inconsistent will cause you serious heartburn.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me on Twitter @Joel Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.